Hello there. This video is all about the binomial probability distribution. So this is our first probability distribution. It is a discrete distribution. And let's talk about some of the criteria before we jump into it. The experiment is performed for a fixed number of times, that's n times, and each repetition is called a trial. The trials must be independent. Now, if you remember, independent means that each trial does not affect the next trial, or vice versa. For each trial, there are mutually exclusive or disjoint outcomes, meaning it is either a success or a failure. The probability of a success is what we're going to call P. Probability of a failure is 1 minus P, it's the complement. I often use Q to represent the complement, and other textbooks do that as well. The probability of a success remains the same for each trial. So, for example, flipping a coin. Each flip of the coin is 50% will be heads, a success. Or it's not, which would be a fail. Now here we have the binomial probability function, and you can see it's a little complicated. The main parts I want us to see and pay attention to, and this will be the last part of this lecture, will be the mean and the standard deviation. And we will come back to those in a little bit. But I want to talk about the probability distribution function. Living in this day and age, it is an amazing time. So we are actually not going to have to even use that. We can use our calculators. Yay. So I want to take a look here and make it clear for a TI. We are going to have a binomial distribution. And we are going, and I'll show you on the calculator here in just a moment. So you can see the binom CDF and PDF. We'll talk about the difference between those in a moment. So that is binom CDF. And the order is going to be, it's going to be N, comma, P, comma, X, and the X has to be less than like we have here. When it's greater than, we'll talk about what to do with that. For a Casio, it is going to be, I'll show you where that is. So if you go to Options, Stat, Distribution, and here's your binomial distribution. And you can see binomial CD. And that is going to be a different order. That is going to be X less than as well, comma N, comma P. I'm going to use only TI since most people have a TI, but there it is for Casio if need be. Once again, only less than is going to work. Otherwise, we'll have to kind of fake it. So in the TI, I'd like to show how to find this. So here we have our first scenario where X is less than 5, but there's a total of 8. I want to show you what I mean by that. So we have the possibility that there are no successes. There's 1 success, 2 success, 3 success, all the way up to 8. And they want to know what the probability is if we have less than 5 or 4 or 3 or 2 or 1 or 0 successes. So we're actually adding each of these independent ones up. That's the CDF. CDF means that we have more than one, we're adding up those probabilities. The PDF means we want to know when X is exactly 5. So for example, this one is X equals 4. That'll be a PDF when we get to it. So what we want is less than, so we want, in this case, 5 and down. So here's what this means for our calculator. I'm going to go to distributions again. And here's my binom CDF. Again, PDF is for the equal case. Less than is going to be the CDF. And there's a different format for sometimes with the TI-84s. I'm going to stay with this format here. The order is still the same. So this is going to be 8, comma, 0.3, comma, 5. Because 5 is included, you see the less than or equal to symbol. Then I just hit enter. And there it is. So you should write down what you type in each time. Binom CDF 8, 0.3, 5, and that was about 0.9887. So what we're saying is the probability of this event occurring, there's 30% chance that it's going to occur. And what's the probability that it will occur 0 times, plus the 1 time, plus the probability 2 times, 3 times, 4 times, and 5 times? What's the probability of all those added up together? Well, it's quite high, nearly 100%. Meaning 6, 7, and 8 are going to have fairly low probabilities of happening, especially because there's only a 30% chance that it will happen. Let's try this next one below it. Now, I want to bring up my paper here. So this is from the previous one that we just did. This next one, 0, 1, 2, 3, 4, 5, 6, 7. You don't have to write this out, but I think it makes it easier. You'll notice there's no equal symbol with this less than 4. That means what we want is 3 and down. So notice we're excluding 4 because they did here. Here we included the 5 because it was included. So in this case, what we're going to enter into the calculator. Once again, you should be writing this down each time. I'm just going to show you how to do it with the calculator. For full credit with your test, you most likely, I'm going to want to see that when I give you a test. So binom CDF, 7, 0.6, comma, and again, that's going to be 3, as we saw in the previous, because that's strictly less than 4. And there we have it. .289792. You may need to round off at some point, which is fine. I have one more that's less than, and can you see that 3 is included in this case? The probability of each trial being successful is only 0.2, and there are a total of 9 trials. So I'm going to bring this over here. This is going to be binom CDF 6.2, and here I'm including 3. Binom CDF 6, 0.2, 3. And that gives me 0.98304. Now, we don't know what these numbers necessarily mean at this point. That'll make more sense in the next video when we use an application to do this. I want to show you, there's another interface. If you go to mode, and this is only the newer ones can do this. So you see the stat wizard, I have it turned off. I like it turned off, I prefer that. If you turn it on, then the interface is quite different. So it actually sets it up like this. So for this one, it would be 6.2 and 3. And it's actually going to paste exactly, you see it pasted exactly this onto there. And we end up with the same thing. I'm going to turn the wizard off just because, I prefer that. But feel free to leave it on. Makes it a little bit easier in a way. Okay, now, I said it only works for less than, which is true. I want to go to this one here. So this is from those previous 2. Here we have 10 trials, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. N is 10, and what we want is 7 and bigger. So what, I'm sorry, notice 7 is not included. So we actually, what we want is 8 and bigger. But we don't know how to do greater than. Our calculator doesn't do that. So here's what I'm going to do. I'm going to trick it. I'm going to say, I want to know 7 and down, and then find its complement. Here's how we're going to write that. So this is going to be 1 minus binom CDF 10.4 and 7 and on. 7 and down, I should say. Once again, because 7 is not included with what we want, it is included with what we don't want, which is the opposite. That's why I did the 1 minus. And I'm going to do this one Casio, just so that some of the Casio users can see it. So I'm going to do 1 minus binom CD. And again, your order is going to be 7, comma, 0.4. I'm sorry, that's not right. 10, comma, 0.4. So again, you are X, N, and P. So this one here, ooh, I'm going to squeeze that in. And the TI would look like this, 1 minus and then 10, comma, 0.4, comma, 7. You can see we get the same number. I'm going to try this one. This is N is 8. Zero, 1, 2, 3, 4, 5, 6, 7, and 8. We want 5 and bigger, so what we want is 5 and bigger. So what we're going to have to do is the 1 minus 4 and down. So again, in this case, because they included the 5 here with what they want, the opposite would be 4 and down. This is 8.9 and 4 and down. So 8, comma, 0.9, comma, 4. So if I round that off right. And I'm expecting that you're practicing every single one of these with your calculator just to get used to the interface. Now we have one last one to do here, and this one's an equal. So now instead of CDF, this is going to be the binom PDF. The order will be the same, 8.5 and 4. So this is exactly equal to 4. That's why we used the P instead of the C. All these were adding up a bunch of them. So we have distribution. And now it's binom PDF. 8, comma, 0.5, comma, 4. Point 2, 7, 3, 4. Pardon the bad handwriting. So go through these, practice these a few times maybe. Just make sure that you get used to your technology and your calculator. Here are some buzzwords that could be helpful. And we are now to the next page with some applications. So Larry's batting average is 0.2, or 200 we would say as if you're a baseball player. And the number of trials is 5 times at bat. That means n equals 5 for us, for all of these questions. So this, of course, is P. How likely is it that he'll get at most 3 hits? At most 3 means that what we want is 3 and down. So I'm going to go, and so this one's less than, so this is x is less than or equal to 3. This is CDF again because we're adding up number. If he gets 3 hits, 2 hits, 1 hit, or 0 hits. So once again, this is 5, 0.2, and 3. 5, 0.2, 3. Yep. So quite high. So there's a really good chance he won't get any hits or one hit. Those are his highest probabilities because he's not all that great of a hitter. 2 hits, probably not. 3 hits, really probably not. 4 or 5 hits, that's going to be a very low probability, so that's why we got such a high one, adding all the 0, 1, 2, and 3 up to get 0.99328. How likely is it that he'll get fewer than 2 hits? So 0, 1, 2, 3, 4, 5. So fewer than 2 hits means 1 and down. This means that X is strictly less than 2. Binom CD F, this is 5, 0.2, and 1. 5.2 and 1. So get less than fewer hits, pretty good chance he's going to get less than 2 hits, 1 or 2 hits. That's going to be his highest probability most likely, again, because his batting average is only 200. How likely is it that he'll get at least 2 hits? Do you see that that's exactly the opposite of this one here? At least 2 hits? So I'm going to do a little trick here. I'm actually going to go 1 minus this previous problem here, because it's exactly the complement. So this is exactly equal to 0.26272. So these two are complements. How likely is it that he'll get 3 hits? So this means X is exactly equal to 3. This is going to be PDF. Binom PDF 5.2 and 3. Again, this is the P because it's exactly equal to. So getting 3 hits is probably not something that Larry's going to be able to achieve here. So practice these again, just to kind of get used to the calculator and its functions. This next part is we're going to check for unusual. Again, that's going to be plus or minus standard deviation. If you remember, on the second page from earlier, I told you we were going to come back to these two. So I'm going to write those two formula down. So we have that mu is going to be NP, and sigma is going to be the square root of N times P times Q. And if you remember, Q is the 1 minus P. Now there's one other piece here. We have to test this here, and you'll notice that's the square of that. It's what's referred to as the variance. If this is bigger than or equal to 10, then the distribution will be approximately bell-shaped. So we'll have to test for that as well. So those are our 3 main formulas that we're going to be looking at as we proceed to this last part. So here we have, according to an almanac, 70% of adult smokers started smoking before turning 18 years old. Here's P. Compute the mean and the standard deviation. No problem. And N in this case is the 300. You see that there. So 300 times 0.7. 300 times 0.7 is 210. Sorry, the lights turned off. The standard deviation is the square root of n times p times q. So that's going to give me the square root of n, which is 300, times p, which is 0.7, times 1 minus 0.7 is 0.3. This is about 7.9373. So we're going to interpret the mean. The mean means it is expected in a random sample of 300 adult smokers that 210 of these smokers would have started smoking before they turned 18. Seems reasonable. If 70% is the number, that seems reasonable. Perform the check on the condition that allows us to conclude that the binomial distribution in this case is approximately bell-shaped. That's the n times p times 1 minus p, or q I use, is bigger than or equal to 10. That is from the previous page, right here. So this gives me 300 times 0.7 times 0.3. Let's see what that is. Actually, that's this. I'm just going to square the previous answer. 63. You could just multiply it out as well. And 63 is clearly bigger than or equal to 10. So, approximately bell-shaped. Would it be unusual to observe? Remember, unusual or usual means 2 standard deviations away in either direction. So I'm going to go mean minus 2 sigma and the mean plus 2 sigma and see what we get. That's 210 minus 2 times 7.9373 and 210 plus 2 times 7.9373. And let's see what we get. So 210. 210 minus 2 times 7.9373. So the lower boundary that we're going to have is 194. We'll say that's about 194. And I add it, 210 plus 2 times 7.9373. And this is going to be my upper boundary of what would be usual. And I'll say 226, since these are people, they're whole people. So they're asking if 255 would be unusual. So $194, 226. So in here, this is my usual range. Out here, this is my unusual. And 255 is way out here. So the answer is unusual, because that's way outside my usual range. And I'm going to leave this one for you to do. It's very similar to this one here, so go ahead and take a few minutes and go through the second one here and see what you get.